Cybercriminals are always looking for innovative techniques to evade security solutions. Attackers are actively leveraging tools allowing them to generate malicious shortcut files for payload delivery. These tools allow them to generate files that appear as legitimate Microsoft Word, Adobe PDF, zip archives, images such as JPEGs, PNGs, audio MP3s, and even video. Today, I'm going to show you a payload that I developed that will automate this process for you. This payload will allow you to inject code into all the shortcuts on your target's desktop. Anytime they use any of those shortcuts, your script will be run in the background unbeknownst to them. Let me show you how it's done. While this payload can be deployed in a number of ways, for today's video, I'm going to be using one of my favorite devices from the Hack5 store, the OMG Plug. This is a device that allows you to perform remote keystroke injection attacks against your target. Simply connect the device to your target's PC, and then connect to the device with your phone or laptop, and you're ready to go. Right here is the Ducky script itself that you will want to have on the plug. It will use a simple Invoke WebRequest command to download and execute your script on your target's PC. I'll have an Invoke WebRequest tutorial in the description below, along with a link to where you can get an OMG plug for yourself. Now, in order for you to understand how this payload works, you need to understand a link file and its properties. When I run the get shortcut function on a Google Chrome link, it will return the following information. The link property is the displayed name of the link we will be modifying. The target path is the path to the file that the shortcut itself is pointing to. When looking at the link's properties, you can see a field called target. This is where that information is stored and also what we need to modify for this payload to work. Next, we will be looking at the icon location property, which is the location of the ICO file on the system. This comes in two parts. First, we will have the target path again, and this will be followed by the index, further specifying where in the DLL file the icon is actually stored. In this case, the index is 0, indicating it is the first available icon. We are going to take all of this information we have gathered and use it to modify the link file in a way that it will maintain functionality while also running our code undetected in the background. I want you to truly understand what is going on when you run my payload. Copying and pasting my final code makes you nothing more than a script kiddie. So let us now look through the functions that make this payload possible. Maybe you learn a thing or two to help you develop your own payloads. The first function we are going to go over is one you should already be somewhat familiar with. The get shortcut function is used to enumerate a shortcut link file. We will use this function to parse all the necessary data and store it in an object. This object will later be called on and modified as seen fit for our payload. The second function we will look at is the set shortcut function. We will use this one to create and replace the shortcut that we are targeting. The variable containers will also be created here. In the third and final hijack function, we will be passing the information we gathered from the get shortcut function into the set shortcut function. Yes, I could have combined the last two functions, but I opted to leave them separate to make it easier for those who want to try and modify these functions for their own purposes. Anyways, it is here that we will also be injecting our script we want to run in the background into the shortcut. This is where the magic happens. Now, at the very bottom of the script, we also have a single line of code that we need to go over that is crucial to this payload. This single line is what will allow us to hijack all of the shortcuts on the target's desktop, or whatever directory we choose. Let's break it down. First, we will use the getChild item and the filter tag to get a list of all the shortcuts in the designated directory, in this example, the desktop. Next, we will pipe that list into a for each statement that will run the getShortcut function to enumerate each of the shortcuts, followed by running the hijack function on each of them to embed the designated PowerShell code into each of them. This line can be modified to hijack the shortcuts in any or all directories, or only target shortcuts with a certain name for more targeted attacks. If we go back to the top of the script, you will see a code variable that has some PowerShell code stored in it. This is what will be injected into the shortcut. The example code here will just open a dialog box that says hacked, as you've seen before. Now, how do we make this happen, you ask? So you remember when we were going over the shortcut properties and I was telling you how the target input field is where you store the actual path to the file that you want to run? Well, what not a lot of people know is that you can actually run PowerShell commands directly from there. Let me show you what I mean. Looking back at Google Chrome's Properties tab, we can see in the shortcut target field, it is pointing to the actual location of Google Chrome's executable file. Now, if we erase all of the data stored in this field and replace it with a PowerShell command that, for example, starts Notepad, we can repurpose the shortcut to do just that. However, notice when we hit apply what happens. It changes the shortcut's icon. Now, this doesn't always happen, and sometimes just happens when the computer is rebooted, but regardless, we are not going to be fooling anyone when their Google Chrome shortcut link looks like this. However, if you remember, we used the get shortcut function to grab Chrome's icon location. So when we use the set shortcut function to add PowerShell code to the target field, we will also reset the shortcut icon just in case. Now, in order to do this inconspicuously, when they click the shortcut, we want it to open Chrome like it's supposed to, and then run the code we set in the background. So we will need our PowerShell code to first open the file stored in the target path variable we set up earlier, then run our PowerShell code after. Something to keep in mind is the command to run Chrome in my case is 55 characters long, and this text box, like the run box, can only store 259 visible characters. Now, what do I mean by visible characters? Well, as it turns out, when I use this payload to inject PowerShell code into the target box, I noticed that it would still run just fine even if I broke the 259 character limit. And after doing some testing, I noticed that it actually let me inject a script up to 924 characters. It's just you can only see the first 259 characters in the text box. If your script is longer than that, you may need to just use something like Invoke WebRequest to download and execute the script when they click the shortcut instead. I'll have a tutorial for how to do that in the description below. If you have made it this far, congratulations. You are now ready and well on your way to wreak havoc. I made this payload with the intention of it being used on call center scammers, so hopefully this makes its way over to one of the scambaiter channels. It would be an honor to see this used to cause mayhem on their systems. But anyways, I am Jakoby. My crime is that of curiosity. And yeah, curiosity killed the cat, but satisfaction brought him back. Till next time.